Good morning. This Leibniz rule of definite integration is a very important topic for WBJEE maths. Every year, not only WBJEE questions you can find in JEE main and advanced also. Every year they ask questions based on the concept of Leibniz rule of integration. The basic concept is given in NCERT textbook only, where if the area function given this manner, ax equal to a2x fx dx, this will represent the area bounded by the curve between the curve and the x-axis. But this area function, which is known as first fundamental theorem of integral calculus, this will be equal to f dash x, just fx. E dash x is the derivative of the left hand side, which is given by the function fx only. So if you have a function like, let fx equal to say 2x cos x squared dx, then the value of derivative of the function differentiating with respect to x, you can write f dash x equal to cos of x. Okay. So this concept already discussed with you earlier, but here the discussion will be mainly on where the two limits both are variable. Okay, like if there is variable in the upper limit, there is variable in the lower limit, then how to solve those sums, how to find derivative, this is our main problem we are going to discuss now. Okay. So the Leibniz rule of definite integration will be like this. If there is a function fx which is given by the integration with these two variable limits, say gx and hx fx dx, then the derivative of fx, the left hand side, f dash x will be f of plug this function into fx multiplied by its derivative h dash x minus f of gx. You are plugging this function into fx, this multiplied by derivative of gx. Okay. So this is Leibniz rule. We will proceed without giving any proof of it. Okay. No proof can be given at this moment where there is examinations one by one. Proof is not required also. Just accept this as Leibniz rule. You can use it to solve problems in definite integration. And in those exams, they will be linking concept of Leibniz rule with the concept of tangent normal, the concept of maxima minima, all these. So let us start with this simplest problem where fx is given this manner, say x square to e to the power x sin t dt. Okay, you have to find the value of f dash x. Just find f dash x. So your answer will be like this. Differentiating both sides with respect to x, f dash x, which is nothing but dx of fx sin of, take this function here, into derivative of e to the power x, this minus sin of the lower limit, x square into dx of x square. So this will be e to the power x sin e to the power x, and this is 2x sin x square. Hope you have understood. This is not very difficult to understand. Just let us solve one more problem where the lower limit may be a constant. This is say 0 to x cubed root over cos t dt. Your problem is to find the value of f dash x. So what you will do here, this is 0, okay, plug 0 into it and that part will never come if this is a constant one, that area function problem. So here, differentiating with respect to x, f dash x going to be under root cos of x cubed into ddx of x cubed. This minus under root cos 0 into ddx of 0. So this will be under root cos x cubed dx square, although this part is non-zero, root 1, but this part always be 0. So you can ignore the second part of Leibniz rule here. Just concentrate on the first part. Let us take another one. Say fx is given to be x to x square sin t dt. Your problem is to find f dash x. How to? This is very simple, and they can ask you some like this also. I am just writing. Given fx equal to 0 to x dt by under root 1 plus 4t square and f double dash x equal to k into x, then find t. Okay, see the problem now becoming bit more difficult here. So how to find f dash x here? One more problem on it just for your practice. How to find f dash x here? You'll follow the Leibniz rule. Here x square will not be there inside because x square is a constant. Okay? X square is a constant means in terms of that variable sin t dt. T is the function over there. So you can easily keep x square outside. So rewrite fx here will be x square outside, x to x square sin t dt. Okay? So to find f dash x, you have to take care of the product rule of differentiation here. If you go by derivative of this part separately, just doing say this one only, by taking this one another function hx equal to x to x square sin t dt, then h dash x will be, you'll be taking x square inside, then derivative of x square is 2x, x inside, this part we are doing by Leibniz rule, then derivative of x is 1. So 2x sin x square minus sin x. Hope you have understood. So once more I tell you, take x square inside, then derivative of 2x minus x inside, then derivative of x. This part is h dash. So this one changed to x square into h. Agreed? Now find derivative by product rule. First function derivative into hx. Hx means what? This whole function x to x square sin t dt, this minus x square into this part, sin x square minus sin x. Okay? And this part you can do by integration ordinary, that minus cos t. In fact, you could do it in the beginning only. Just to apply Leibniz rule, we are doing it. Sin x square. Just simplify it by using the upper limit and lower limit concept. 2x square, the upper limit is what? Cos x square plus cos x minus 2x cube sin x square plus x square sin x. Now let us go for this problem with a change, little bit change. This is y given. 0 to y given x equal to, next problem, and this part is not f double dash x d square y by dx square equal to kx, then find the value of k here, ky here. Okay, then find the value of k. Given x equal to 0 to y dt by under root 1 plus 4t square and d square by dx square equal to ky, then find the value of t. So again, for this problem, we have to bring y into the picture. So x is given 0 to y dt by under root See, when you are differentiating, we have no problem with dt. dt can be there. Okay. So, how to find derivative of this thing? Lower limit is a constant. So, you can use the concept of area function only. That ax equal to zero to x fx dx, a dash x will be only fx. So here, if you differentiate with respect to what? Differentiate with respect to x. So this is 1. Here, you take this function inside, 1 plus 4y square, derivative of y with respect to x, dy by dx, minus, you need not do, just I am doing it for Leibniz rule, 1 plus 4 into 0 square dx of 0. Hope you have understood. So here, for this sum, dy by dx going to be under root 1 plus 4y square. Okay? dy by dx equal to this thing. Under root 1 plus 4y square. Now find d square by dx square. It will be ddx of into dx by dy. It is ddx of this, so we'll apply chain rule over there. This should be what? The dy of 1 plus 4y square, this multiplied by dy by dx. Okay? It's alright. Just find the derivative of this thing. Half 1 plus 4y square to the power half minus 1 into its derivative. That is what? 1 plus 4y square derivative, 0 plus 8y into dy by dx. Clear? So this is going to be 1 by 2 root over into 8y into dy by dx. That is, so these two getting cancelled, it is 4y. They have given d square by dx square is ky. Here you got 4y. So on comparing we get k equal to 4. Alright? Hope you have understood. There is no problem in it. Just let us see application in increasing and decreasing function. Okay? Find the interval in which fx equal to minus 1 to x e to the power t minus 1 2 minus t dt, and given x greater than minus 1 is increasing. Find the interval in which this function is increasing. Hope you can do it without my help. Just try. I write the next sum. Find the point of local maxima or minima of fx equal to t square minus 1 by e to the power t plus 1 dt. Find the point of local maxima. Application is being done in maxima minima and in increasing function. Then we'll find application and limits. Okay, first let us complete these two sums. Find the interval in which this is increasing. So you find f dash x and then use the condition for increasing and decreasing function. I remind you the rule again that fx is hx to gx, fx dx. This is Leibniz rule. Here f dash x will be f of gx into derivative of gx minus f of hx into derivative of hx. Just apply it and get the interval where it is increasing or decreasing. This is 2 minus t. Replace t by x. Derivative of x is 1 minus, you need not do the lower part because lower part is a constant, that hx is minus 1, its derivative will be equal to 0. That's why we will ignore if there is a constant. So done. So f dash x is now e to the power x minus 1, 2 minus x. Okay. For increasing or decreasing function, derivative should be greater than 0 or less than 0. For strictly increasing function, you take any value of x. Any value of x. I just remind you the approximate value of E. You know this infinite series. 1 by factorial 2, 1 by factorial 3, it continues this up to infinity. So this is always greater than 2. And by approximation, I can show you E is approximately equal to 2.74. Approximately. Any square root, cube root, whatever you take here, that will be greater than 1. Okay? You understand what I say? Just otherwise, you can plot the graph also. Just let us do the graph here for e to the power x. This graph is for e to the power x. Okay? It is less than 1. It is less than 1 e to the power x minus 1 is less than 1 before 0. Because when this is the graph of y equal to e to the power x, this point is 0, 1. Okay. So if you draw the sign scheme of this part, e to the power x minus 1, before 0 is negative, e to the power x minus 1. Two functions are there. This is say hx and this is gx. For increasing function, this product has to be greater than 0. If you take minus sign outside, e to the power x minus 1, x minus 2. This will vanish at 1 and this one at 2. Okay? This is 1. 1. Before 1, this part is negative. This part is also negative. So negative, negative and negative. Their product is negative. So it is not increasing over there. In between 1 and 2, what do you find? In between 1 and 2, this part, e to the power x minus 1, this is, before that there is a negative sign. This is positive, but this one is negative. Got it? So whole function, f dash x will be positive over there. Here f dash x negative. And here, beyond 2, you have a negative sign over there. E to the power x minus 1 positive and x minus 2 also positive. So their product f dash x will be less than 0. So this will be increasing in which interval? Your answer going to be fx is increasing when x lying in the interval only this part. Okay? Hope you have understood. Let us go for application in maxima and minima. Find the point of local maxima and minima for this function, for this one. How to? Find the point of local maxima and minima for this function. Lower part again constant, so this part will not consider. F dash x will be replace 3 by x square into 2x. Hope you have understood. So this is going to be 2x x square minus 1 x square plus 1 by e to the power x square plus 1. This will be 2x x plus 1 x minus 1 and x square plus 1 by, clear? And for this particular sum, I tell you to go by the first order derivative. Okay? So let me take the critical point, that is at 0. Oh, minus 1 is also. Minus 1, 0 and 1. This will never vanish. This one also. They are always positive. This part is, but this is always positive. So we don't have to think about these two parts. If you go by first order derivative, they are positive. Now go by the sign scheme of the remaining part. Okay? Before minus 1, what happens? You start with positive sign here, plus, plus. odd indices are there, you know that wavy curve method, this will be negative. Here again, when you are making the point, when you are crossing the point 1, then index is 1, odd, that's why sign changed. When you are crossing 0 here, this part is 0, x minus 0, this index is also odd, so put plus sign. X plus 1, its index is also odd, change the sign here. Okay. Now it is obvious at which point it has maximum or minimum. If dash x changes sign from where to where? Negative to positive. If dash x changes sign from negative to positive. Here at this point what happens? If dash x changes sign from positive to negative, what happens here? If dash x changes sign from negative to positive. If it changes sign from negative to positive, so minimum occurs. Where does minimum occur? Minimum occurs at -1. Minimum at -1. What about this point? Changes sign from positive to negative. Maximum at 0. And here again minimum at 1. Don't take the risk of second order derivative. It's too long to decide. First order derivative is of great help here. Hope you have understood the sum. Now let us see how limit problem can be solved by using the concept of Leibniz rule. Okay, the problem is given this manner. If x equal to, no, let gx equal to x into the power x square, and let fx equal to 1 to x dt into t plus 1 by t dt. Compute the limit f double dash x by g double dash x as x tending to infinity. Okay, so this is a big one. You have to find this thing actually. You have to find limit x tending to infinity f double dash x by, can do it by L'Hopital rule, no problem. Okay. So what you will do here, you simply find f double dash x, you simply find g double dash x, then it's over, and put there. Before doing that, you can check what's going to happen at this spot. If dash x is what? If dash x is what? The lower part you don't have to consider. You use Leibniz rule. Dx x plus 1 by x, isn't it? Gx into x plus 1 by x, because derivative of x is 1. I did not write that. Lower part is a constant, so Leibniz rule, if you apply, that will be 0. If dash x is found. What is f double dash x? F double dash x is g dash x 1 plus 1 by x square. No. G dash x, go by product rule, plus gx into 1 minus 1 by x. Okay? Gx is a given function over there. F double dash x is found, you go for gx. Gx is what? X e to the power x square. So g dash x you can find easily, that will be x into 2x e to the power x square. Okay? Now, one thing you will always observe, the function going to be very big. If you do for second order derivative, then also very big. So what to do? Will you proceed or you will think different manner? G double dash x will be 1 plus 2x square and then again 4x. Everything is found out over there. G dash x, G double dash x, everything you got there. If you put it there, it will come definitely. But there is one alternative way that I will show you. You just put it there by first method. F double dash x you got G dash x e to the power x square plus gx into 1 minus 1 by x square. Clear? That divided by G double dash x plus, so e to the power x square extending to infinity, so this part will not be 0, you cancel it. So this problem now reduced to this thing only. 1 plus 2x square, x plus 1 by x. You take the LCM into by x plus by x square, that divided by plus 4x, isn't it? So this x square on LCM will be coming in the denominator. So x square, here also you can take 2x common. And numerator plus x into x square minus 1. Obviously, we are going to apply L'Hopital rule. And we will remember, limit extends to infinity 1 by x square x cube, that will be 0. So to apply it successfully, what you need to do? You need to divide by the highest power of x. x5, you divide numerator and denominator by x5. Both inner and rear. x tending to infinity. So here it is x to the power 5, you give x squared to this, x squared to this, and x here 1 by x squared plus 2, and here whatever you give, this will be 0 because x tending to infinity. And here if you divide 2 into 3 by, you are giving x cubed here and x squared here plus 2. Hope you have understood. When x tending to infinity, this part will be 0 plus 2, 1, this part will be 0, and here 2, 0 plus 2. So this will be 2 by 4. Answer is 1 by 2. Hope you have understood. It's not very difficult. Try to understand again what I have done there. Then I'll tell you what is the easier method to solve this. Because you may not be very good at L'Hopital rule. The L'Hopital rule is valid for the given function numerator by denominator. It is valid for their derivatives, it is valid for their second order derivatives, third order, fourth order, whatever. So you think you are going back. L'Hopital rule I am telling you, limit x tending to infinity fx by gx. If the form remains 0 by 0 by putting x infinity, this is 0, this is 0, then you can differentiate. If dash x by g dash x, again say by putting this is coming 0 by 0, you can differentiate again. And this is true for 0 also, 0 and infinity by g double dash x. This is true for any limit. Okay? Not only infinity, this is valid for extending to a also. Okay? Only condition is that the numerator and denominator should be both 0. So for this sum, this will be your homework. The second order derivative is given here. If I tell you to go for the first order only, this may be convenient for you. You just rewrite this as, because we have got it from first order derivative, you must take a wise decision here. Such a big calculation, before you try, go back. Okay? So just put f dash x, just put g dash x, and then proceed. This will be easier, no? F dash x is what here? Gx into x plus 1 by x. So, and that g dash x is what? G dash x is e to the power x square 1 plus 2x square. Okay? So e to the power x square getting cancelled. Divide numerator and denominator by x squared, the leading term. Just check here. Just I am writing here. X squared plus 1, that divide by. So how do we evaluate this? Divide by x squared, both inner and rear. It will be 2x plus 1 or divide. You can differentiate also, there is no problem. On this function, you are going forward, okay? Differentiate or divide by x squared. See, these two getting cancelled, answer is coming half. X not equal to infinity, tending to infinity. That's why you can cancel. Hope you have got the concept of Leibniz rule and its application in 3 chapters. Mainly they ask question From here, in all entrance examination, on increasing, decreasing, maximum, minimum, and limit.